Hello and welcome to our C++ fundamental course. In today's lesson, we are going to explore basics of integer data types. It's very important because integer data types represent whole numbers, which were widely used for many tasks like counting, indexing, and math operations. Let's start with a simple task where I want to calculate the average of two numbers. So first we need to declare and initialize these numbers. Let's name them a equal to 6 and integer b equal to 8. And when I want to calculate the average of this number, let's create output to our console. The average of a and b is, and let's calculate our average as a plus b divided by 2. End line. Okay, now let's build our program, check that everything is fine. And you see that everything is fine, so let's now test our program. And you can see the resulting output, the average of 6 and 8 is 7. Okay, but if we want to make sure that our program is working for all cases, we need to test different numbers, negative, zeros, and of course very big and very small numbers. So let's now try to test some very big numbers like 2 billion. And if you want your big numbers to be more readable, you can separate thousands with apostrophes. Now you can see it much better. You can instantly see that it's 2 billions and b will be equal to 1 billion. Okay, the average of 2 billions and 1 billion is 1.5 billion that I expect to see in my output. Let's build and run our code again. And you can see that result is quite strange. The average of 2 billions and 1 billion is some strange negative number. I didn't expect this outcome, so it means that something is wrong with our code. The issue that arises in my code is the fact that sum of a and b exceeds the maximum value that can be represented by integer in C++. So yes, this is a very important feature of C++ and C++ integer types. When you declare integer type, you allocate fixed amount of memory. In this case, when we declare integer, we allocate exactly 4 bytes of the memory. And 4 bytes is equal to 32 bits. Each bit is value 0 or 1, so you can calculate how many numbers you can store in integer type. It's a bit more than 4 billion, and since for integer we need both negative and positive numbers, so integer vary from -2 billion to 2 billions. And when I sum a plus b, if I accidentally get number bigger than 2 billion, in my case a plus b is 3 billion, I got this error because C++ don't allocate bigger amount of memory for me. It's not Python. Here you should really care about your memory. So now when we know about this restriction, we can actually fix our code. Instead of a plus b divided by 2, I will divide a by 2, and then I add b divided by 2. But of course in this case you will get error if you have odd numbers, so think about it and use doubles here. Now let's check that our error is fixed. And you can see that in this case everything is working because we care about our memory restriction, and we got our result 1.5 billion. So what can we do if we really need to work with bigger integers? We can use different integer data types. For example, instead of integer, if I know that all my numbers I'm going to use are positive, I can use type unsigned integer. Unsigned integer can store only non-negative numbers, so they vary from 0 to roughly 4 billions. And now if I need to work with a bigger integer, let's here initialize a with 3 billion and b with 4 billion. We can't use this numbers 3 and 4 billions with the regular integers, but now if I use unsigned integer that allows me to work with these numbers, you can see the average of 3 and 4 billions is 3.5 billions. Now let's modify our task. Let's say I want to find not average of two numbers, but average of the members of vector. And in this case, I need to include class vector to use vectors in our program. And now let's declare our vector. It will be once again a vector of integers. I will name my vector nums and members will be 1704. So first I need to find the sum of my members, and in the cycle 4, let's sum all our members. Now when we found the sum of our vector, let's change our output message. So the average is our sum divided by size of our vector, nums size. Okay, and now let's check the result. 1 plus 7 plus 4 is 12 divided by 4. I expect to see outcome 3. Let's build and run our program. And you can see that indeed the average is 3. Now let's test some negative numbers. I want to test this vector, -1, -7, -4. So now I expect the outcome -3. Let's build and run our program. And you can see that once again we got a really strange result. Instead of -3, the average is some huge number. It's very strange and confusing for us as a beginner programmer, but the problem here is in the data type of the function size. Usually we don't really think about the data type of outcome of some standard function, but actually the outcome of the function size is not integer, because containers can't have negative size. Negative size containers can't exist. So why should function size return integer? It will actually return the unsigned integer type, and there is even special name of this type, the type that function size return. The name of this data type is size t, and it's unsigned integer. So what is happening here? When C++ try to divide integer, the number that can be negative, by num size, the number that is positive, it's a bit confused what should be the outcome, signed or unsigned type. And in this particular case, C++ will try to convert signed type, sum, to unsigned type. And when we try to convert negative number to this unsigned type, we got this error. So how to avoid it? Of course, we should use static cast. So I'm going to use here static cast, and I'm going to cast my num size variable to integer, and let's check the result in this case. And you can see now, when we know that the outcome of num size function is unsigned type, and we know about this conflict between signed and unsigned type, we use static cast, and now we got safe and correct answer. The average of this vector is -3. So let's talk about this restriction in more details. What if I'm not sure that in my current architecture the size of integer is 4 bytes, because there was some old architecture where integer were restricted to 2 bytes, and also maybe I'm not sure what's the size of this size t data type, because actually size of size t data type depends on your architecture. If you work on the 32-bit machine, the size of the size t is restricted by 4 bytes. If you work on the 64-bit machine, size t occupy 8 bytes. So how can we check it? We can use function sizeof. So let's now delete all this code because we don't need it anymore. And let's create the outcome sizeof integer and line. And the function sizeof will return me the amount of bytes that integer occupy. Let's build and run our program. And you can see that indeed on my machine, when I declare integer, I allocate 4 bytes of the memory. Let's check size t. I work on the 64-bit machine, so I expect size t will be 8 bytes. And you can see that indeed size t occupy 8 bytes. Let's also check unsigned int. I expect it also to be 4 bytes as a regular integer. And you can see that indeed unsigned int takes 4 bytes. Okay, now what's about our limitation? How can I find out the minimum and maximum number that our data type can store? Of course, I can Google, but once again, it can vary on different architectures. So if I want to check restrictions on my machine, I first of all need to include library limits. And now when I have this library, I can use special functions that allow me to find out the maximum and minimum possible number that this type can store. Okay, so let's create some nice output. Size is, so I'm going to type size of my function. Then I want to type maximum possible amount. And now to type this maximum possible amount, I'm going to call for numeric limits, and in the triangle brackets I'm going to specify numeric limits of what data type I want to know. Then use colon colon, scope resolution operator, and function max, and once again end line. And now in the same way I want to find out the minimum possible amount. So minimum possible amount of integer, and here I need to call function minimum from numeric limits. Okay, now let's build and run our code. And you can see that size of integer is 4 and maximum and minimum possible amount. In the same way, we can check all integer data types we know. Let's check size t. Let's build and run our code. And you can see that the size of size t is 8 bytes. And here is maximum and minimum possible amount that size t can store. You might remember that when we discussed data types in our very first lesson, we also discussed such integer data type as short and long. Let's check limitation for short integer and long integer. Okay, let's build and run our code. And you can see that size of short integer is 2 bytes and maximum possible amount is 32,000 and minimum minus 32,000. So if you want to save your memory, you can use this 2 bytes integer short. Let's now check long. Okay, let's build and run our code. And you can see that long actually has the same size as regular integer. Let's also check long integer. Let's build and run our code. And you can see that size of long integer is 8 bytes and it has this limitation. So if you need to work with really big numbers, if you want your program to allocate more memory, if you want some very high precision, maybe for some scientist task, to work with some big data, you can use long integer. Okay, we discussed all standard data type, but information is still confusing because I might want to write code that I'm going to run on different architecture, and I'm not sure if on other computer of my fellow, the size of integer will be 4 bytes, not 2 bytes. And also maybe he or she is going to use 32-bit machine, so the size of size t will be 4 bytes, not 8 bytes. So we need some way to guarantee the size of our integers. And we can do it as well by including library cstdint to our program. And now when we included this library, we can work with such integer data types as integer 16t, integer 32t, integer 64t, and integer 8t. And as you understand, in this data type, amount of bytes is fixed. So if I'm going to use integer 32t, I will create some variable of this type. And now if I try to check the size of this variable, and also limitations of our type integer 32t. Well, but actually to check the limitations, I still need to use library limits. So now let's build and run this code. And you can see that now we are 100% sure that our integer 32 has size 4 bytes, and also we guarantee maximum and minimum possible amount. If I need, for example, 2 bytes unsigned integer type, I will use type int16t. And now if we check this type, let's build and run our program. And you can see that now we guarantee that this type is unsigned, its size is 2 bytes, and also we guarantee maximum and minimum possible amounts. So this is it. If you want to be 100% sure about your integer types, if you want to guarantee that your program is going to work the same on different machines, use cstdint library and use these data types where size is fixed. So we've learned the limitation of different integer types. Let's now also ask ourselves the next question. What exactly happens when our variable overflows and no longer fits the memory allocated to it? So I want to create a variable integer, and I want to create a variable that is equal to the maximum possible value of our integer type. And actually for standard integer, there is a macro so you can use to call for the maximum integer. It's called int max. And now let's say I want to type to our console a plus 1. So a is equal to the maximum possible amount that integer can store. Let's check what will happen if we add 1 to our integer. Let's build and run our program. And you can see a very interesting outcome. When we add 1 to maximum integer value, the result is equal to the minimum possible integer value. So this is a very important feature of C++. When you overflow your maximum integer, you don't go anywhere. Result is actually quite predictable. You will get to the minimum possible value of integer. Let's now check the same with the minimum, with the smallest possible integer. What will happen if I subtract 1 from the minimum possible integer? And I think you already know what will happen. When I subtract 1 from the minimum, from the smallest possible integer, I will get to the maximum integer. Not everywhere result is quite defined. Minimum integer minus 1 is maximum integer. So this is very interesting feature of C++ language, and using this you can solve many mathematical problems, but we're not going to dwell into it and talk about how to add, multiply, divide, subtract different integer types among themselves. So we already know that if I try to perform mathematical operation on signed and unsigned type, the compiler will convert both type to the unsigned type, and result can be unpredictable. So for example, if I create integer a equal to minus 5 and unsigned integer b equal to 3, and if now I try to type to my console the result of multiplication AB without thinking about their data types and how they are going to be converted, let's build and run our code. And you can see that here, when I do this multiplication without thinking about safety of my code, instead of minus 15, I got this unpredictable result. So once again here, when I know that I need to multiply signed and unsigned type, don't forget to use static cast. Okay, and now our code should work. Perfect. So I actually created a table for you with all casting integer rules, and from this table you can see that when I use two small integers in mathematical operation, the result will be always integer. But when we are using bigger data type, now results are more interesting. So when I add, multiply, divide, subtract two integer with different size, C++ will cast both size to the bigger size. So if I multiply 32-bit integer with 64-bit integer, the result will be 64-bit integer. And when I multiply, add, or whatever, signed and unsigned type, the result will be always unsigned type. So you should always remember about these rules when you work with your integer data types. Okay guys, this is it about integer data types. If you still have some questions, I will be very happy to discuss them with you in the comment section, and see you in the next lesson.